All right, so this is 8.2 still. We are still on 8.2. Analyzing arithmetic sequences and series. So this is video number 3. Now we're going to write a rule given a term and a common difference. In the last video we were given the first term. We could tell what the first term was and then the common difference. But this time we're given some random term in our series or sequence. Sequence. All right, so let's give this a try. Okay, we're going to write a rule. And in number 5, I'm given the 19th term and the difference of -3, which means to get from one term to the next, we get -3. Or we add, add -3. So, let's give this a try. So what I'm going to do, it does tell us then graph the first 6 terms in the sequence after that. So, don't want to forget that piece of instruction. So I'm eventually going to need this graph over here. All right. So remember our formula that was AN equals A1 plus N minus 1, times D. That's a D on the end. I've put in parentheses. I don't know why. Don't need it. Okay, so I'm going to plug in what I know here. Because what I need for my rule, the only 2 variables I need are A1 and D. And I know D, but I don't know A1. So I'm going to use this A sub 19 equals -45. Okay, I know when I'm on term 19, AN will be -45. So I'm going to plug that in. When N is 19, AN is -45. Okay, so think of this as N, and this is AN. And I'm just going to use this to help me find A1. Okay, so AN is -45. I still don't know A1 because that's what I want to find, plus, and N is 19 minus 1 times D, which I do know is -3. Okay, so this gives me an 18 times the -3. Okay, so I end up with -45 equals A1, let's see, it's going to be a -54. So to solve for A1, I'm going to add 54 to each side. And I end up getting A1 is going to equal -45 plus 54 is 9. So here's my first term. Here's the D, and I can now plug it into my rule. Okay? So AN is going to equal 9 plus N minus 1 times -3. I now ignore this whole part right there. I only use that to help me find that A1. Okay? Alright, distribute your -3. AN equals 9 minus 3N plus 3. So AN equals a -3N plus 12. Okay, there's my rule. And then it wants me to graph the first 6 terms. To do this, I find it easiest to find those first 6 terms. So if I draw a table here, and you can do your table the other direction the way we were doing it before, or whichever, N being the X values, AN being the Y values. Let's see, we already know the first term is 9. This -3 just means I'm subtracting 3 each time. So let's see, 2, 3, 4, 5, 6. Okay, so if I subtract 3, I get 6, 3, 0, -3, and -6. Another way to do this is we know that the y-intercept would be 12, because look, this is in slope-intercept form. But my first term and my slope, and my slope is -3, so I go down 3, right 1, and that gives me the first term. You could do it that way too without doing the table, but this makes it a little easier to graph. So at 1, 9, let's see, do these go up by 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm glad I counted. Okay, and then at 2, 6, 3, 3, 4, 0, 5, -3, and it's hard for me to see because my graph's not so good, but here is the graph of my first 6 terms. Look, they make a straight line. All right, let's give it a try on number 6. And again, I don't want to forget to graph, so I'm going to leave a blank graph over there. Okay, so I'm going to use the rule an equals a1 plus an n minus 1 times d. I already know d, but I need to find a1, so I'm going to use this to help me do that. Remember, this will be n, this will be an. Okay, so 52 equals a1 plus 12 minus 1 times 6, because I already knew the d. Okay, I plugged in 12 for n, I plugged in 52 for an. Alright, so this makes 11, so I get 52 equals a1 plus 66. Okay, we got to solve for a1, so we're going to subtract 66 to both sides. And I get that a1 is going to equal negative 14. Okay, so when writing my rule, I know d and I know a1. I'm going to write the rule. So an is going to equal negative 14 plus n minus 1 times 6. We distribute the 6. So an equals negative 14 plus 6n minus 6. Collect like terms and rewrite it. So 6n minus 20 is our rule. There we go. And we need to graph those first terms. So again, we could do a table. 1, 2, 3, 4, 5, 6. Plug 1 in for n. See what you get. Okay, I get negative 14. 2n would be 12 minus 20. Or you can see that we're adding 8 each. I said 14, but I wrote 4. We're adding 6 each time. That's that number multiplying n. So add 6 each time. So this would be a minus 2, positive 4, 10, and 16. So if I go to graph it, I don't know if this goes down to 14. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14's way down there. And then negative 8. Negative 2, 4, it's up at 4, then it's up at 10, then it's up way off the graph. I should have had my graph upside down. That one's not even going to show up. My 16 is not going to show up. But there's my first terms. You see they make a straight line because this is linear. Alright, so I now want you to go to your practice and do problems number 24 and 26. Move on to the next video.